to the meeting options here. And I will be allowing people to bypass the lobby. And I'm admitting the people right now. Alan, when you are ready, you can start.
Steve's going to start, isn't he?
I'm afraid, yeah, sorry. Steve, please do start. Thank you.
Yeah, well, I'm watching a number of people zooming up here on my screen. So I've got 38 so far.
If you'd like to wait a couple of minutes, feel free to do so.
Yeah, just make sure everyone's admitted. Yep, no problem. So we've got about 40 people on so far. I'm sure that will increase as people are admitted. This is the first time we've tried Teams, so you may see some issues as we work our way through that, but just bear with us. We'll be starting that. So that's a minute after 12. So I'll welcome you and say good afternoon to this presentation on energy transition from the IMechE. We have a number of experts with us today who are going to tell us what their opinions are on the commercial opportunities and barriers for the transition, what's stopping that actually happening. One of the first things I'll ask you to do is if you could open your Q&A box. I see the number of people being admitted is increasing. So if you could open the Q&A box, there's a tab up at the top there, and that will allow you to ask questions of the audience as we go through the presentation. And that will allow us to answer as many questions as possible when we get to the end. I can see that the number of people being admitted is increasing, so we will just wait a minute or two, and then we're getting up to 50 odd now. So today we have presentations from Alan Barton, Willie Tulloch, Dr. Fiona Sillars, Patrick O'Hara, and Clethenthus Demathis. And then we'll have a short session where we are going to try and answer your questions, a discussion session, etc. Right, we seem to have stabilised at the number of people. So, Alan, if you would like to share you're sharing your screen. If you want to start your presentation now, I think we've stabilised at the number of people being admitted.
Okay, well, good morning. Thank you for calling me an expert. It's first time I've happened, I think. Anyway, I'm going to talk about sustainability, but sustainability in all things. And I think humankind has got itself into a bit of a mess, mainly caused by our increase in population, particularly in the last 250 years, and especially since the end of the First World War. And equally, our focus on producing more products and services to finance the way we live. And we've been very ingenious. And what we have done, though, is we've increased the global temperatures, and we've done that by using carbon as our energy source. And in March, I went to Antarctica to see firsthand the impact of what we're doing, and I was horrified to actually witness glaciers melting. And this year in Antarctica, the ice cap is thinnest it's been, as you can see. And one consequence is somewhere in the region of 10,000 emperor penguins died of hypothermia because when they fell into the water, their down coats don't keep them warm. But more significantly, the poles drive the ocean currents, and the increase in temperature is slowing those currents, and that will have a great impact on our temperatures, but equally on the nutritions that move around. And it's my belief we need to go back to a circular ecology, and we need to develop a circular economy. We need our home to be circular and the way we manage it. But we need carbon to be in balance. And we need to break the link between energy and carbon dioxide. And we can do that by grabbing our energy from the sun, various ways, or grabbing it from gravity. Equally, we can grow organic material, which is short chain cycle on carbon, and we can either turn it into energy or we can make fuels. And this is a picture of the first plane to fly across the Atlantic on a renewable fuel. But equally, we can maybe develop even more advanced technologies. And it's my belief, if the energy source is in the ground, maybe we should leave it there as soon as we can get through a transition. And yes, we can do carbon capture, but I think it's, well, I always questioned, we spend billions of pounds taking fossil fuels out of the ground and more billions of pounds turning them into power. And then we're thinking about spending trillions of pounds to put the carbon back in the ground again. I just asked the question, why don't we leave it there? And we've set ourselves a goal, but we need to make this transition and we need to do it quickly. And I sort of thought, well, what are some of the barriers? Well, I think one of the barriers is we haven't got good advice from our scientists and engineers to consider the complexity of all this and actually inform society of the facts so society can make some important decisions. And we need everybody to take responsibility and to start to do something, which isn't happening. We've also got to realise it's incredibly complex, but we do need a clear path based on science and engineering to lead us in the right direction. And we do need our politicians to deliver on their promises. And I think the best book on leadership I've ever read is Shakespeare's Henry V. And Henry decides he's going to invade France, and he tries to canvass support, and he's got comes up against naysayers, critics, and traitors. And the naysayers are the ones that say, Henry, I'm quite happy going down the pub. I don't want to go to France. The critics are the ones that say, Henry, yeah, okay, you want to invade France, but I think you're going about it in the wrong way. And the traitors are those that actually say, yeah, good idea, Henry, but behind his back, try and scupper it. Well, he had a choice with the traitors because he could send them to the Tower of London. And I'm going to go through a list now of some of the barriers, and I just ask you to consider what ones you think are the traitors. Well, the first, the autocratic countries, Russia, China, they really do need to step up to the mark and do more. And I feel for the leaders of the oil, gas and coal companies because potentially their businesses are going to go out of business. But we got to realise it's going to cost us more money potentially, and we're in an economic downturn. And I also think there's a lack of engineers. To look at the amount of infrastructure we need to build, how are we going to do that? I think another real problem is that the major issue is in the future. It's 50 to 100 years time before we're going to see the real impact. We're starting to see it now, but it's going to be a lot worse then. And there is generally a lack of urgency. And there is this lack of clear, sound advice to give society. And we need a joined up plan, and it needs to be consistent, and it needs to be for 30 years, not changed every 4 years. If you look at the opportunities, well, just look at the drivers. We've got greater population. We've got this focus on producing goods, and we've got to do something about carbon. And we've got initiatives trying to achieve that. And we need a completely different set of engineering solutions to our problem. And we need to do it quickly. So it's my belief that the opportunities from this abound. And I think, you know, what a great opportunity for a young mechanical engineer to become part of the efforts to save our home. If I had 3 wishes, well, the first one would be we would realise that our ecology is global without national boundaries, and we would get a global solution, and we'd break the barriers, and we get these guys, or they're the ones in power now, to do something and do it now, not in the future. Second wish would be we'd make a giant leap towards sustainability in all things and the resources that support all life on our planet. But most of all, I would get everyone to consider sustainability in all things and not just sit there do something. Because if we don't, we can potentially end up like this. If we do, and there are encouraging signs, there is hope. Thank you very much. So I'm now going to stop sharing my screen. I'm going to work out how to do that.
Thanks very much, Alan. Alan, I forgot to introduce you. So I'm going to
I'm
do
an
that
expert.
now. He's an
Yep.
expert. And for the past 15 years, he's worked for Arup, a global engineering consultancy, as their business development leader for resources and waste. Prior to this, he worked for 20 years at Shanks, which at the time was one of the leading waste management contractors. He's also held a number of non-executive directorships and advisory boards. Excellent. And while I've done that, Willie has shared his screen and is unmuted, so excellent. So I'll introduce Willie, our next speaker. Willie's passionate about all things engineering and energy, a highly accomplished senior industry expert in the energy sector for over 20 years in oil and gas, and he has a vast experience in delivering transformational change, driving improvements in the efficiency and safety performance of onshore and offshore oil and gas facilities. He's recognised for his strong technical and business background with a track record of shaping and implementing robust business strategy, underpinning high performance value creation, and he's an expert. Willie.
Good afternoon. Thanks for that introduction. I can't believe you're talking about the same person there. So welcome everyone, and thanks for joining today. So I guess across all the panelists, you'll hear different views on the same topic, and I guess that's what makes this whole topic really interesting, and it does divide opinion. But I'll start here with this ratio. You know, we're all probably engineers on the line or on the call here today, but I would challenge anyone to say that they've seen a ratio of this scale. It's absolutely enormous, and I guess if you weren't all muted, I would ask the question, you know, what does this represent? Well, what it actually is if you take it on a linear scale, it's the population growth over the last 200 years. So imagine the planet. Alan's talked very passionately about, you know, sustainability. You know, we're adding, or we have been adding 35 million more people to the planet every single year for the last 200 years. Now, that's not linear. If you look at this since the end of or around about the end of the Industrial Revolution, you can see it's actually over the last 100 years that we've seen an even greater increase in the number of people on this planet. So it's actually more than 35 million in a year that we're adding in terms of people. It's an absolutely phenomenal number of people, and if you consider that in terms of the impact it's having on the resources of this planet. So, you know, considering energy, look at, you know, just over the last 20 years, energy demand has gone up by 50%, which is absolutely phenomenal, and that's across all the different sectors. Obviously, we've been relying on fossil fuels predominantly to meet our energy needs, and now obviously the focus with more you know, being more conscious about the climate and the impact that's having on that, and we're moving into renewables. But as we know, that can't happen overnight. You know, that's got to be a gradual transition. And here you see in the larger scale, again, very similar to the trend that we saw for population growth, the actual world energy consumption growth, again, from the end of the Industrial Revolution to the present time, or nearly to the present time, resembles a very similar path. And the same, you know, CO2 emissions is following exactly the same trend. So you can see all of this is intrinsically linked. And I guess what we see here is, you know, the demand placed on the planet's resources can seem, you know, like it's a very complex balancing act, as we see here. You know, trying to satisfy all the aspects. So well, it comes down to supply and demand, essentially. And it's, you know, in this case, in energy, you know, whether it's the environment, energy security, and cost of energy. But for me, it's really quite simple. It's not that complex. And again, Alan talked about this. It's sustainability, the impact that we have, the choices that we make, in terms of materials, how we go about our daily lives all comes down to sustainability. There's a cause and effect to everything that we do. And as we know, it's, I guess, been very much in the news, right the way through this last period. There's, I guess, some difficult decisions that having to be made in terms of how we meet our energy needs. And even on a political stage, there's significant divided opinion, and also in the public. But if you look at the impact, there's again that the granting of new oil and gas licenses is going to have. You can see here the plot in terms of where we're at. We're very much this is in the UK continental shelf. So you can see oil and gas is very much in decline, and the light sort of pink purpley line or section at the tail end of the decline here is what the additional licenses is basically going to add to our production. And really, in the grand scheme of things, it's not much at all. Yeah, in the northeast of Scotland, where I'm based here, I mean, it's a massive employer, but essentially that's not going to meet our energy needs, and we're going to continue to rely in this country on imported energy. So you can see here the gap between the supply and demand. So, I mean, yes, we're seeing opportunities in oil and gas, but we cannot take our eye off the ball in terms of businesses, organisations, and even individuals working in the industry. We absolutely need to be making that transition, and that's regardless of any impact on oil and gas. On the climate. And again, we're also seeing, as I say here, headwinds in the renewables sector. A lot of projects now are being reappraised effectively because the cost increases. That in some cases the costs have increased 20 to 40%. There's massive issues around resourcing, wage increases. In terms of the CFD, so the contract for difference that the government sets, so basically the levelised cost of energy for these projects. Again, it's not sustainable. Companies that are investing in this area, at the end of the day, have to make money. And we've also got supply chain issues. And if you take one example in offshore wind, to meet our targets, we need to be basically manufacturing approximately 1.8 million tonnes of steel per annum. And that is basically what the annual or the global annual output of steel production is for meeting all our needs at the present time. So again, that is going to be a significant challenge addressing how we basically fix that shortfall. At the moment, we're seeing, and in my opinion, I think almost quite a biased view from the in the media, and this again presents a significant challenge to us as engineers. We're fundamentally what the country, or a big part of what we do, the country's relying on us to come up with the solutions to basically address this situation. But I guess, to some extent, this here almost creates this impression that there absolutely needs to be a degree of urgency. But ultimately, as I said before, oil and gas absolutely remains part of the mix. So for me, it's not about shutting it off immediately, because that is just not the reality. Is that's not going to happen. But how do we actually reduce the impact of oil and gas in the short term? And we need the smartest minds out there to be able to do that. And also for the general public now, it's very difficult to actually understand what's true and what's basically false. And I think Alan touched on this. It's that there needs to be better clarity. I think we're potentially getting sidetracked to some extent by even the targets that's being set, the 1.5 degrees increase in temperature. There's absolutely an increase in temperature, but how much of that is down to background effects of the, just as the planet changes, and how much is due to, well, basically fossil fuel production. There's no doubt, as I said earlier, you can see whether you're a skeptic or whether you're absolutely aligned to the whole climate issue, a change of 1 billion to 8 billion people is absolutely going to have an impact to some extent on the planet's resources. And also what we're seeing now as well, if you look at the energy trilemma, are the public being switched off to some extent? Because at the moment we've got a cost of living crisis. So really, the short-term view is, it's how much it's costing them in the pocket. Inflation is through the roof. As I say, cost of living is what's in front of everyone's mind. So really, I think it is some of the figures I saw quoted, or one of the figures I saw quoted, was maybe 60% of the public were in favour now of basically energy security in our domestic oil and gas supply, which is ultimately potentially going to have a significant effect on meeting our targets that's been set in terms of net zero. And as I say, a lot of what we're doing, it's not all about the production of fossil fuels. One of the biggest impacts we can have is around, as I say here, culture and behaviour, how people use that energy. So looking at more efficient ways, reducing our demand, and if we can do that, then we can also, to some extent, start reducing the impact that we have in that. And I would argue to some extent that's almost something that can be done much more quickly than, as I say, that transition away from from fossil fuels to renewables. Also, when you look at this is very topical, I guess. Unless you've not been watching the news in this country, most will have heard of HS2, and I guess beyond those shores, if you've heard about it, it's maybe even more worrying. But the optic that we're creating here in this country, and I'm talking about the challenges that we've actually got, is are we presenting ourselves in the best light in terms of attracting international investment, because green investment is going to take basically the building of wind turbines, hydrogen, the alternatives to fossil fuels is going to take significant investment in infrastructure to get us to that place. And at the moment we just don't have that capacity. That even just focusing on the manufacturing capacity, we don't have that in the UK. So we need to be creating an environment and an optic where we're a safe place for investors to invest their money, and also for companies to come and work. And AECOM set out or produced a paper setting out a strategy to basically identify 6 key areas that we need to address to essentially make us make the UK a more attractive place to do business, particularly where it's large infrastructure projects. So if we look at the market, the scale of the market that we've got, there's a general consensus now on the importance of obviously decarbonising the global economy in order to mitigate the significant and physical, economic and social risks from climate change. But we need more clarity on the pace and possible pathways that would enable us to do this. I mean, we've got roadmaps for everything these days, but they all need to start converging on the same point. And what we see here is, I guess, the competitiveness of the the UK industry. So our average is sitting at 2.5%. That's our average competitiveness. And I guess there's some key observations you can make here where oil and gas is sitting below that. Manufacturing is maybe not a surprise. Agriculture, these are all areas where we have strong heritage and we expect to be, maybe higher up in terms of where our competitiveness is. So that's an opportunity. And also, if you look at professional and admin services, so that includes the likes of engineering, consultancy, etc. We're strong in that area. So those are areas that we can basically sell that expertise globally, particularly in meeting the demand for that skill sets in energy transition. And I guess in the context of what we're talking about here, all of this, there is a strong link to energy all the way through that. And if you look just purely at the EU in terms of the technology groups, as we call it here, the actual size of the prize that we've got from 2020 to 2050, they're projecting that as much as 25 trillion pounds will be spent or required to be spent to meet our targets on essentially net zero. So there's a massive opportunity. And I guess for a lot of companies now is, how do we take advantage of that? How do we actually understand our place in the market? And for me, it's about the value chain. Do we understand, or do you understand where your business is? The value chain is right from the raw materials all the way through to producing the products. And I mean, this is a fairly simple analogy and definition of what the value chain is. But your business that you work for might sit across multiple sectors of that value chain. You might be in one small part, but I think understanding how you can essentially fit into that value chain, whether you're an existing organisation working in oil and gas, or whether you're already in renewables, but you can expand. What I just showed earlier in the previous slide is there is a massive opportunity for businesses to create new market sectors and huge value from basically getting involved in the energy transition. And the UK, is a proud engineering history. And here's an iconic example that we see here. This is the Forth Rail Bridge, which spans over the Firth of Forth here in Scotland, and this has stood for more than 200 years. But one of the things, it stood on solid foundations. So again, what we need here to give us a solid foundation to map our way forward is a steadfast, basically energy security strategy that's essentially not subject to change depending on what political parties in power at the time. It's basically a clear strategy that all the cross-party support that we can all align to, and that ultimately then starts to build confidence in terms of where we're going as a country to meet our energy needs. And I think given that certainty, we'll see a significant acceleration in the steps we take to move forward to address the energy transition challenge. And I guess a key part of that plan and meeting that challenge is our resources, our skill sets. At the moment, we're estimating that we've a shortfall of engineers of between 39,000 and 57,000 per year. That's what we're going to need from that figure was from back in 2021. So from 2021 to 2024, that's the number of additional engineers that we need to meet the shortfall, which is massive. And what's the plan? What can we do to meet that challenge? And there's a great LinkedIn article by Wissam Gadbano Kent, that's ultimately discussing the evolving skill sets required in energy. In the past, employers focused on hiring individuals who excelled at, finding solutions to complex problems. But this emphasis on problem solving was a reflection of the workplace that celebrated human ingenuity and the ability to craft solutions. However, now in the era of digitization and recent advances in AI, this has moved significantly. So, we're going from being solution providers to question askers, is essentially. And I mean, that couldn't be more exciting for, I think, the next generation of engineers coming into the industry. But while the momentum towards renewables is essentially, it's inevitable that the oil and gas industry remains a crucial to meet the current global energy demands. And addressing the expertise gap, is going to require a multifaceted approach that not only attracts new talent, but also reassures them of the industry's relevance and commitment to the evolution of sustainability. So as I mentioned before, because there's still a reliance on oil and gas, we need the smartest minds out there. We need to be attracting the best talent, the new engineers coming through to help us find the solutions to minimize that impact while we transition away from fossil fuels to renewables. And we've got a terrific opportunity. This is the recent top 200 universities in the world according to the Times survey, and you can see here in the UK we have some of the best educational institutions in the world. I mean, this is obviously across every aspect, so or every sector, not just engineering, but we absolutely need to be engaging the institutions, and it's not only that, it's engaging the students, the new engineers coming through, to get them into basically our industry and supporting the path going forward. And I'll just finish here. This is my son and his mother, and when we couldn't be prouder of the fact that he's chosen to follow a career in mechanical engineering. He enrolled on his degree at Heriot-Watt University in September, just last month, and really, that this is what we ultimately what we need to be doing, is inspiring the next generation that there is a fantastic future. Engineering presents a great career, and in particular being involved in the energy sector. And as Alan said, the range of opportunities is absolutely enormous. So let's hope that we can inspire a lot more and fill that gap that we have at the present time. So thanks very much for listening to me, and I'll pass back to Steve.
Hi, Willie. Thanks very much, Willie. That was really good. We've had some people join us, so I'll just say one more time, if you could open the Q&A tab at the top there, and if you put your questions into the panel there, we'll get round to them at the end and see how many we can answer. So we're a wee bit behind time, so I'm going to abbreviate your introduction, Fiona, while you unmute and get your slides up. So I've got introduced Dr. Fiona Sellers. She's team lead of Advanced Materials Research Laboratory at the University of Strathclyde. She's an expert in materials chemistry, degradation, behaviour, performance, up to mechanical loading and fatigue life. She's delivered over 100 interdisciplinary research projects since 2012. And our research has been funded by EPSRC. She's worked on energy storage for electric vehicles, buildings as power stations, for Tata Steel, the Solar Soldier, wearable power generation as well, among many other things. Fiona, are you ready?
Yeah, I think so. If everyone can see me, the screen.
Excellent. Yeah, I can see that. Thank you.
Great. So today I'm just going to give a quick overview of where, obviously I'm coming from the University of Strathclyde, so our perspective from commercial side is slightly different. So I'm just presenting sort of where we see the opportunity and where we're focusing our research on. So the area that we've been looking at is reuse, repurpose and remanufacture, and this is across all industries. But I'd just like to give maybe a couple of examples of how we're doing this. So For hydrogen generation, transport and storage, obviously, it's one of the key areas that we're looking at to reduce our reliance on fossil fuels. It can also be generated from both renewable sources or blue hydrogen. But to meet the net zero targets and the timescales that we have, we would have to reuse or repurpose the infrastructure that's already there. We're never going to get by 2050 an entirely new infrastructure for hydrogen circulation. So basically, what the opportunity is how do we repurpose this infrastructure? How do we prove that it's safe to do this? How do we utilize the knowledge that's already within the oil and gas sector on hydrogen and hydrogen embrittlement and use that again to prove this safety case? In terms of the barriers, that there is a knowledge gap about the effect of hydrogen on steel embrittlement and other materials. Obviously, we have to look at all components in the system. There's no guidelines on this. There's no clear standards for the safety justification for either new pipelines or reuse of existing pipelines. And we don't fully understand the effect of hydrogen on the structural integrity of the pipelines, dents, corrosion, defects. How is the hydrogen going to interact with these, and how do we prove that that is okay to move forward with it? Another area that might not seem, obviously, green industry, but we're now seeing that actually these green industries, we need to be constantly keeping an eye on the supply chain, green industry, brown supply chain. So we started working a few years ago on circularity in the wind industry. So we've worked with SMEs based in Scotland, and we're basically looking at repurposing these turbine components that would normally go to a skip in landfill. I don't even know if they were recycled. So basically we look to develop refurbishment programs to put these back into the economy. And in doing this, only looking at one or two components, they've already recirculated 3,400 parts, saving 400 tons of CO2. So that's one small company that is doing this, and it's now thankfully growing momentum among the larger OEMs, realizing that this has to happen. But it's still a barrier. So they're still slow at the uptake of this. They don't like the thought of remanufactured components. So now we call them recirculated components. Where they are coming into it is that these can be more readily available. So instead of something being down for 6 months waiting on a component, it might be only down for a few weeks because we've got one that can be refurbished sitting on a shelf ready to go. The other barriers are addressing this lack of confidence in the recircled parts. That's still a technical challenge. So that's still for engineers to look at and prove that the components are, the fatigue life of the components is satisfactory. The damage is limited. There's minimal damage, but these are all things that we have to be able to provide at the end users with confidence. One of the other things, and it's a barrier just now because it's not happening, is decommissioning studies need to be happening 5 years before they're currently happening. They can't start a few years before these wind farms are going to come to the end of their design life. They need to start before that. And then, yeah, it needs buy-in from companies, from ourselves as engineers, and then there's got to be funding available to seed this type of idea. Another opportunity I'd like to present to everybody is obviously to work with, I think Willie touched on it a little bit, working with universities. We're able to provide multidisciplinary teams for large projects or small projects as well, and basically build that technical knowledge to start to roll out this sustainable future. We have various engagement models. We're able to do small collaborations through, obviously, if you're based in Scotland, we can do innovation vouchers. It's slightly different in the rest of the UK. There's catapult funding, there's impact accelerator equipment, then there's larger ones, Innovate UK, knowledge transfer partnerships. There's lots of funding available to utilise and benefit from that relationship with universities. And as you start to engage with us, obviously, again, as Willie's mentioned, we're able to feed that into the undergraduates and get them interested in working with, you know, still staying within the process industries, within the oil and gas sector, but doing it sustainably and bring that to the forefront. So I think that's me.
Thank you, Fiona. That's excellent. It's good to hear some positive things coming out of this, opportunities coming from this this issue. Okay, so I'll allow you to shut that down and then let Patrick share his screen, and then we will introduce Patrick. Patrick O'Hara is an engineer with 2 decades experience in separation process and pressure systems, primarily in oil and gas. However, he's additionally encompassing water treatment, pharmaceutical, nuclear, and green hydrogen sectors. And I can see your slides, Patrick.
Excellent, thank you very much. I'm trying to put forward a bit of a pragmatic view because the whole debate around this has become very heated and people are very much believers or non-believers, and it shouldn't be about a belief system. So let's just look at some facts and ask some questions and think where we could go.
You're on mute, Patrick.
Sorry about that. I didn't realize on mute there. So let's take a pragmatic look at climate change and the energy transition. So we as a society rely entirely on fossil fuels, not just to provide 80% of our energy needs, but also as vital feedstocks for plastics and fertilizers for feeding the world's population. Basically, if we stopped using oil, most of the world's population would die either through a freezing to death or us being unable to grow sufficient foods. However, they are finite and cannot be replaced on a realistic timescale. So we do need to find an alternative regardless of the climate argument.
You went back on mute again.
You must be pressing some button somewhere.
Yeah. So the Earth's a carbon cycle. People talk of the evil of carbon. Carbon is essential, and carbon-based energy is essential for every living thing on Earth. That's how plants grow, that feeds people and animals. So yes, we are having influence, but we must not regard carbon and carbon-based energy sources in themselves evil. So let's look at some facts here. Carbon dioxide levels are around 50% greater in the atmosphere than they were pre-industrialization. And global temperatures have risen by about 1 degree in the past 4 decades. We also know that increased carbon dioxide levels lead to increased rates of plant growth, which turns the world greener and also helps us feed the world's population. Now, we've got a theory that the observed temperature rise is directly driven by the increase in CO2 levels, and that continuing to increase CO2 levels will lead to a corresponding increase in temperature. But that's very much a theory. The data doesn't completely prove it, and the climate system isn't fully understood. So we need to bear in mind that we shouldn't stake everything on that definitely being true. And we also think that any climate change will only have negative consequences. So some questions we might all ask, what is the right temperature for Earth, and we talk about a 1 degree, 1.5 degree rise. In a typical day to night cycle, the temperature moves around by about 10 degrees. and yet the world doesn't come to an end. So it's just a food for thought there. Excess cold kills 10 times as many people every year than excess heat. And any consequences of adapting to climate change, are they going to have a larger lifestyle impact on the world's population than the impact of removing that reliance on fossil fuels? And again, what's the right level of carbon dioxide in the atmosphere? Is there a right level and a wrong level? But the problem with the current message that we're sending out is we're telling people that if they don't completely change everything they do and become poor, that they might have to change everything they do and become poor. And it's not a particularly great message, I don't think. And the people delivering that message inevitably don't practice what they preach. They're flying around all over the world in business jets to go to conferences to tell people that they shouldn't fly around the world. And this a country by country race to net zero doesn't actually look at what we're doing to total global emissions, and maybe that same money could be spent better in actually achieving a better global reduction in emissions. And pressure groups trying to prevent fossil fuel development clearly don't understand their value as essential feedstocks for fertilizers and for plastics. Do our politicians even? No. Potential opportunities from doing this are quite huge, though. You know, I make reference to the lunar missions and the Apollo program, which was quite unpopular at the time and very expensive, and you could argue possibly pointless, but it led to a whole load of technological advances. And we may get that out of the energy transition approach that we're doing now, even if some of them turn out to be dead ends. We're already seeing that with a leap forward in a battery technology, which we're getting. And the UK aims to be net zero by 2050. What is net zero and how do you calculate it? If we offshore all our manufacturing jobs, which it's starting to happen now largely because of the price of energy, and if we keep on increasing it, at the moment we generate about half our energy, our electricity, using renewables. If we continue to make it more expensive, they then may head off to China, where they'll be generated using dirty coal. So have we actually achieved net zero then? Probably not. The only real long-term solution is to find a better source of energy than fossil fuels. We are going to have to, because they are finite. And the risks are that people become disillusioned and start, as they can in a democracy, vote in a party that says, let's abandon the whole thing. And the risk, I said, is we export all our energy intensive industries abroad, lose jobs, make the economy smaller, and actually increase emissions. The other risk is that we head down too narrow a technology route and we expend all our effort, resource and money on something that will never actually give us what we actually want. And the other risk is that climate change is inevitable, which all the historical records say that it is. And we can expend a huge amount of our remaining fossil fuels on trying to stop using fossil fuels, but we might be better off holding them back for when the climate does change. A better approach could be to spend our money and our efforts on trying to make the developing countries, India, China, and parts of Africa, give them clean coal technology and that could do far better and carbon capture and storage on a coal than trying to convert all our last gas into a wind and solar that just don't deliver. Just a little bit about hydrogen. It's actually a really bad fuel, a terrible volumetric energy density. So for gas, we'd have to uprate the pressure of our transmission system. In liquid form, it's still got a very low volumetric energy density, fantastic mass energy density, which is why it's used in the upper stages of a rocketry. But outside of that very specific use, where it's fine to keep it in a liquid form for a short period of time, it's really not a great fuel. So what could we do instead? How about if we could use solar power on a vast scale to go and create hydrocarbon fuels from atmospheric carbon dioxide and water, and effectively use that hydrocarbon feedstock to replace current fossil fuel sources of hydrocarbons. And that is actually net zero, because we'll only put back, when we burn it into the atmosphere, the carbon that we've already taken out. I think that might offer the best. It's not been proven to be viable yet, but if it is, it may very well be the best available solution to our future resource and energy needs. Am I the last presenter there, Steve?
Yeah, we're not got onto that slide yet. We'll come off of that. That's great. If you could stop sharing, I will introduce Pathanthus, our final speaker of the day, and then hopefully we've got time for a couple of questions at the end. So, Pathanthus Dimitriatis is a well engineering manager with 25 years international career in Europe, North Africa, and Asia. He's currently with Sasol. He's got significant experience in well operations, well design, research and development, project management. He's mechanical engineer in Greece and he's got a PhD in material science and an MBA in the Netherlands. He's got a bunch of patents. He's co-authored a number of SPE papers, and he's co-founder and board member of the Greek Energy Forum, which investigates energy transition. Pathanthus, I can see your slides.
Yes, thank you. So I'll be very brief because, I think the presentations we had previously were very comprehensive. So my only one slide is a little bit of a reflection on what we heard. Now, there are commercial opportunities, as we saw, abundant, and many of those have to do with engineering, which is of interest to us. An example is geothermal drilling, carbon capture and storage, battery and storage technology, energy storage technology in general. Lithium extraction is another one. And when we're thinking about transition, also the decommissioning of the existing oil and gas infrastructure is also an opportunity. Barriers, of course, exist, and these include legislation and tax regimes that are immature, not fit for purpose. Sometimes, these opportunities also have unattractive short-term returns for someone who wants to invest, and also, as we saw, specialized skills in all these different areas are insufficient at present, and at this rate, it seems that they're going to be insufficient for some time. There are some things that are happening that are in the on the right track. For example, one thing that's happening, and it is good, is how the regulator in the North Sea regulates in a way that gives incentives to everybody to decommission in a most efficient and safest way, and introduce risk-based thinking and technology. So we can use this as an example of how the regulator and the state can usher technology and progress. Now, the one area that I would like to focus, and it's just some thoughts about cost. The energy transition has cost, and the more accelerated we want it, the more expensive it becomes. So I haven't heard a lot of analysis on who will pay for it and how. Inevitably, I think it's going to be a combination between private and public sectors. For the private sector, for people to invest, the returns would have to be attractive in the short term or in the medium term. And this is how the governments can assist here to create incentives and legislation that make this possible. So for the private sector to invest in something that has attractive medium-term returns at least. Now the public sector is a little bit different. The public sector is better placed to make investments that don't require attractive short-term returns, because they have it has a longer time scale, or should at least. Sometimes we know this is not like this because politicians want to be re-elected in 4 years' time, but this is how it should be. So investment in technology and longer-term technologies is better done by the public sector, as we have seen. And now, as we said, taxpayers in the democratic countries will have to be considered, because the long-term vision has to be shared with them. But and we have done this quite a bit, I think, our politicians and special interest organizations. But we also have to make it affordable in the short term, because there are elections every so often, especially in democratic countries. And already we have a cost of living crisis, as we said. It just suffices to see on the television the short-term loan advertisement. So a lot of people cannot afford to pay as things stand, and they are in debt. And I will finish with these thoughts. Thanks.
Thanks very much. You caught me eating my lunch there. Okay, so we will now go on to the questions. We've not got an awful lot of time, but there is a couple of questions that we've got already. And it follows on from that who's going to pay sort of question. You may have noticed that Russia and OPEC Plus have now increased the price of oil. They've now restricting oil, and the oil price is now increasing. The oil industry is suffering from very low investment. It's now no longer the thing to invest in oil companies. And as a result, a lot of engineers are leaving the oil industry. So, in my opinion, the oil price is going to remain high for quite a long period. In the panel, who thinks that's a good thing or a bad thing, a high oil price? Who would like to answer that? Unmute if you would like. Alan, you're unmuted.
That was a silly thing to do. So yeah. Does it discourage people using their cars? If it does,
I think it does.
It's probably a good thing.
It does.
I think I'd share with you the concern about, if you're a young engineer, would you join the oil and gas industry? Because they are still going to be needed for, well, until we make the transition and possibly afterwards. But it's probably a good thing, because if it was really cheap, we'd be using it more.
Yeah, and I think that's why we've used it so much in the past, because it is cheap and it's got a very high energy density. Yeah,
provided it's a globally more expensive, because if Russia's going to sell it really cheap, then that's not necessarily good.
Okay, anyone else in the panel want to answer that?
Yeah, I have a very short answer that high oil price, of course, is bad for faster development, especially in developing countries, but it makes other forms of technology more economically viable faster.
Yeah, it does.
So it's positive and negative, two aspects of this.
Yeah.
Yep, that's why I asked the question, because it's loaded in both directions. Willie, your thoughts on that?
Yeah, I use the word again. It's complex. I guess you know, I look at it from the point of view, you know, if I stick to, I guess, what I kind of covered. It's, well, one, I mean, we don't have an alternative at the moment. You know, everybody's reliant on oil and gas. So really, a high oil price is just putting more pressure on the economy. And the cost of living crisis, because everything is intrinsically linked to that. I guess from the UK's point of view, you know, I showed the gap that we have between supply and demand. So if we're importing more, it means we're again kind of at the mercy of global oil price. And I think you've talked before, Steve, your good presentation last year, which was on the whole thing around the commercial model for and how basically the price of energy is you know, how that's derived. So again, there's probably an element of almost decoupling and basically coming up with a new pricing model for energy. But as I said, it's very it's a very complicated. You can look at it both ways, essentially, as you said.
Yeah. There's another question come through there, Willie. It's probably you touched on it. What is the role of hydrogen in this transition?
Well, I guess it's well, hypothetical. I'm not. It's more than hypothetical. It probably has got a big part to play. You know, Patrick's touched on it. I mean, there's a lot, again, using the word complexities, there are a lot of complexities around it. I you know, my own personal view, it's probably, you know, where it's going to be of most use is probably in heavy industry and in clusters like we're seeing. I don't believe it's the right solution for domestic use. And at the moment, I mean, we're only talking, I can't mind, but a figure that springs to mind, I think it's either, you know, even with the developments that they're that's planned, you know, I think that only contributes something like 5% of the global energy needs. So I mean, at the moment, it's extremely expensive as well. That will change. I mean, they'll come up with solutions, but for me, it's really around transportation and industries is probably where it's got most benefit.
Willie, is that you? Sorry, Patrick, is that your hand up?
Yeah, I know. I agree then, but the important thing to us is that hydrogen is not an energy source. It's an energy storage and transmission medium. And that's what we are using it, and it may not be the best. As I suggested earlier, that if we can take atmospheric carbon dioxide and create hydrocarbons from that using renewable energy sources, that is just as green and as net zero as hydrogen is, because we're not making any net difference to the amount of carbon dioxide in the atmosphere. And we've then got a higher energy density fuel that can also be used as feedstocks for other industries. And we don't need to change our current infrastructure at great cost. We can use it in aeroplanes, in cars, in vehicles, in developing countries. It's just it's an idea of a transport and storage medium, but I very much doubt it will turn out to be the best.
So here in Scotland, we are putting in one wind turbine every second day at the moment, and they're all being plumped in to the Scottish grid, the national grid. The big problem with that is that the power's needed down in England. It's needed down in London. And when you stick that electricity into the national grid, you lose about 40% of it. So that's a big waste of energy and of a facility to actually use energy. So here in Scotland, they're now talking about during times when they can't get the power down to England, converting it to hydrogen. And that makes a bit of sense. That makes a bit of sense because you just cannot, you've got the capability of generating the energy, and if you don't use it, you're basically going to have to turn off your machines and let them rust, which Fiona wouldn't like. So you need to, I think that's possibly where you could get hydrogen. But again, I don't think, as you say, it's a energy source. It's an energy storage method, not a source. Okay. One final question, and then I think we'll wrap up because we're starting to lose people. What is the most impactful thing the engineers can do right now? What do you think is the most impactful thing? Who would like to answer that question first? I'll go around the whole panel and then we'll finish off. Alan, you're unmuted.
Yeah, I've got to learn to mute. What's the most impactful thing we can do? All of us talk in one voice that we need the scientists and the engineers to come up with practical solutions that have been well thought through and get everyone to try and help facilitate that. And equally, go on the website, find out what your carbon footprint, and start asking yourself the question, how do I reduce it?
Yep. So that's an individual thing. But I like the thing about all engineers talking in one voice. I think that would have a big impact, especially when you start talking to politicians who are maybe making decisions based on politics rather than other reasons. Yeah. Okay, who would like to be next? Fiona, you're unmuted.
Yeah, I think it's the same thing, all working together, but I would bring in other disciplines there as well. I think, yes, as engineers, we all need to work together, but I think we do need to bring in the policymakers, bring in the business people, so that we can present it in the correct way so that the politicians listen to us.
Yep, it's got to make a profit one way or another. Somebody's got to make a profit somewhere, or it just ain't going to happen. That's what's important. Dimitriatis, your thoughts on it? You're unmuted.
I will say something maybe a bit controversial. I think an organization like IMechE is within its rights to critique the energy policies of parties before elections and fact check them and have an opinion about them. I think this is its usefulness for the UK society. Although it's politically loaded, I think it would help if there was an impartial review of the energy policies of the political parties.
Okay, excellent. Patrick, your thoughts?
I think whatever is needed, and I think perhaps as engineers, the most impactful thing we can do is give some facts to people that we know, because ultimately it's the electorate that make some decisions. And as engineers, we can all know the right thing, but it's part of our role is to communicate that to the general public through people we know, through conversations at work and socially, and so that at least the electorate have the right information and a full understanding of the facts. Because at the moment, too many people are voting based on a belief one way or another, rather than an understanding of the facts.
Yeah, I tend to agree with that. Just stop oil, go and invade a theatre, and everyone thinks, oh, well, we'll support them for a wee while without some stuff at the back. Okay, and finally, Willie, briefly, Willie.
Yeah, well, I will. I will be brief. So, I mean, I'm completely aligned with the views of the panel, but the other thing I'll add to that is basically what I finished on before, which was basically inspiring more engineers, into our industry, and that's to tackle the challenges with fossil fuels and obviously the renewables as well. So it's right across the full energy spectrum. How do we get more bright minds into our profession to help move forward?
Okay. In that case, I'm going to thank the panel very much, and I'll go to the final slide. Let me see, I can probably, there we go, I'll do this one. Right, let me just get onto the right mode. Can you see that slide, which is from the IMechE, just summarising things? Okay, so there's the way to contact us. If you would like a CPD certificate, contact Muir Islam. He's actually online just now at the IMechE.org to request one, and we can give you that. There's a couple of things coming up. There's an energy transition, geothermal energy and opportunities and barriers. There's a talk on the 30th of November, and that's going to be by the similar sort of team on MS Teams again, online. Same time scale, so please come along and listen to that. Tell your friends about it. The final thing is, in the Aberdeen area, we have a couple of events coming up. So please go onto the Near Me website if you're in the Aberdeen, and there are a couple of in-person events up at Robert Gordon's University. And finally, I'd like to say thank you very much for attending, and that's been great. Thank you.
Does the panel want to stay on?
Yeah, the panel can stay on, and we'll find my way back to team.